Complex numbers. Let's take a look at imaginary numbers, which are the building blocks of complex numbers. Imaginary numbers are indicated using the letter I. I is the square root of -1. If we were to take I and square it, we would end up with -1. This allows us to find the square roots of negative numbers. If n is a positive real number, then the square root of -n will be equal to I times the square root of n. For example, if we had the square root of -4, we could rewrite that as I times the square root of 4. Now we know the square root of 4 is 2, so we have I times 2, and we could rewrite that as 2I. That brings us to the form of complex numbers. Complex numbers are written of the form a plus bi. Here, a and b are both real numbers. We call a the real part of a complex number, and bi the imaginary part of a complex number. Complex numbers can look like 2 plus 3i, or even something like -5i, since that could be rewritten as 0 minus 5i. That also tells us that all real numbers are also complex numbers. If I had the real number 7, I could rewrite that as 7 plus 0i. It does not have an imaginary part, but it is of the form of complex numbers. Let's move on to the powers of I. Suppose we had I to the 0 power. Well, generally, anything to the 0 power is 1. If I had I to the first power, that was just simplified to itself I. I to the second power, we know is -1. Let's investigate what I to the third power would look like. Well, I to the third power is I times I times I. I times I is I squared, which is -1. We now have -1 times I, which will simplify to -I. So I to the third power is -I. Let's consider I to the fourth. Well, I to the fourth power is I times I times I times I. I times I is I squared, which is -1. So we have -1 times -1, and that is +1. It turns out if we were to continue this pattern, I to the fifth would simplify to I to the sixth would simplify to -1, and I to the seventh would simplify to -I. We can use this pattern to help us find a technique for finding higher powers of I. It turns out that if we take any real number n and divide that by 4, the remainder will be some value r. Well, I to that nth power can simplify to I to the r such that that r is the remainder. For example, if I had I to the 22nd power, I could take 22 and divide that by 4. We would get 5 with a remainder of 2. This would mean that I to the 22nd power is the same thing as I squared, which we know to be -1. And that is all.